Hey everyone, continuing for scaling, we'll be looking at the y variable now. And again, it's the same idea as our x variable, where we now have gky equals to hx. So again, let's pull out some examples. I'm pretty sure that it would be intuitive for you now. Let's say we have g1 equals to h3. So originally we had y equals to 1 and x equals to 3. But instead now we have ky equals to 1 and x equals to 3. So what now? Same thing really, is that now if ky equals to 1, we now have y equals to 1 over k. So what was originally 3, 1, so let's say it's somewhere around here, is now 1 over k, 3, 1 over k. So let's say k is a number bigger than 1, then you'll be somewhere around here, right? You notice that your x-axis or your x-coordinates remain the same. So it's actually parallel to the y-axis, right? The line from here to here is parallel to the x-axis. If let's say k is between 0 and 1, then you'll be somewhere around here, right? Just an example. So this is 3 and 1 over k, but same thing, your x-coordinates is the same. The line is still parallel to the x-axis. So what does this do? So the idea is that your y value is now multiplied by 1 over k. So it's a proportionate change to 1 over k as well. And you notice it's the reciprocal of the constant we applied to y, which is k. Alright, therefore it's actually the same logic. It is the scaling, right? So scaling or scale parallel, I'm just gonna write out the whole word, to the y-axis with scale factor or stretch factor. I think scale factor is better. 1 over k. All right, so that is the generic statement transformation for our scaling with respect to the y variable. Of course, there's also a trick for our y equals to fx. All right, so we have y equals to fx. Then of course, if we have y equals to k fx, then it will now be a scale factor, all right, of, now you notice this, now actually this is scale factor k. Why? Now if you think about this, whatever y value that you got, let's say fx is, let's say, a constant h, right? Yeah, y equals to h. Now you have y equals to hk, right? So now your value is multiplied by k, therefore the scale factor is now k. Of course, you can also keep it with the original idea of looking at what happens to y. Instead of applying the constant to our fx, we apply the constant to y, we get y over k. So 1 over k, basically the reciprocal, is scale factor k. Alright, so that's another way to look at it. And up to you, alright, pick your battles. If you want to stick it to one way by looking at the reciprocal as the scale factor, then go ahead. If you want to find it, if you want to do something that's faster, if you're dealing with y, then this is the way to look at it as well. All right, but you need to know at least the generic way. And if you want to know the faster way of y equals to kfx, then go ahead. All right, so otherwise, this is y-axis scaling.